All right, well, welcome. In this video, we're going to be looking at how to subtract rational expressions. In the previous video, you learned how to add rational expressions. Remember, in order to do that, we had to have a common denominator, and so there's a little bit of work involved with that. Now, the good news is that this is almost exactly like we were doing before, except for subtraction involves just one step. Now, that one step sometimes can throw us off, and that's that we are subtracting, and so subtraction means that we're adding a negative. So we're going to do exactly that. We're going to change this to addition, but we can't just do that without distributing that negative. So that means everything in the numerator is going to become negative. We don't distribute the negative to the denominator, so you distribute the negative and change it to addition. Okay, so let's make sure we add that to our notes. Oops, let me rewrite that. Okay, so now it's going to be just like what we were doing before. So we're going to have to do some factoring here. So let's factor this denominator together. So if I look at that, we're looking to see what two numbers multiply together to be negative 16, that add together to be negative 6. So it's going to be a positive 2 and negative 8. The second denominator, what two numbers multiply together to be 8, that add together to be 6, well, that's going to be 2 and 4, because 2 times 4 is 8, and 2 plus 4 is 6. All right, so now remember from yesterday, we're going to identify what our LCM is. In this case, so we start with that first fraction. We have x plus 2, x minus 8. The second fraction, we have the x plus 2, but we don't have an x plus 4. So we need to add that in there. All right, so now we're going to figure out what do we need for each fraction. That first fraction doesn't have the x plus 4. The second fraction, now look at that second fraction is negative x plus a negative 1, remember in our numerator. But our denominator, we have the x plus 2, we have the x plus 4, but we don't have x minus 8. All right, so we know our denominator, it's going to be x plus 2. It's going to be x minus 8, x plus 4. Now in our numerator, we're going to distribute the x through and the 4 through for that first set. So that would become x squared. 1 times x is, just 1x or x. Then distribute the 4 through, so we get 4x plus 4. By the way, as you're working on these, hopefully you're recognizing that these two will always be like terms. So when we do this, if you want to just hold on to x times 1 in your head, and then when we go to multiply 4 times x, recognizing, okay, that's going to be 4x, and write it as 5x. Personally, that's what I would recommend, but I'm going to list it out for these like this, so you can always see where we get that 5x from. All right, let's go to the next set, though. Now, in the next set, we're going to multiply everything by negative x. So negative x times x is negative x squared. And negative x times a negative 8 would be a positive 8x. Remember, that's a negative x we're using. And then next, we're going to use negative 1. So negative 1 times x is negative x. Negative 1 times negative 8 would be a positive 8. So now when I go to combine like terms, the x squared, use a different color, the x squared and that x squared, so x squared minus x squared would be 0x squared, so those are going to disappear. Then we have x plus 4x, so that's 5x, and 5x plus 8 would end up being x, but then we have 13x minus x would be 12x. Whew, so all of that would just be 12x. But again, if you would have simplified this to begin with, you would have recognized that would be 5x. You could have simplified that to begin with and recognized that to be 7x, and then added just those two together, and you'd also get 12x. So personally, that's what I like to do myself, but I know for some students, they can't do that in their head. So I'll show you both steps, both ways. All right, so now we're going to add our constants together. So our constants would just be 4 plus 8, which is 12. Our denominator would be x plus 2, x minus 8, and x plus 4. Now to save myself a little space, I'm just going to recognize that this would be the same. I can factor out a 12. So that's going to be the same as 12 times x plus 1. And that can't simplify at all. So you could we could write the numerator in either form. It doesn't matter. or we could have left it the way it was. But what x can't equal is, since nothing canceled out, well, even if something did cancel out, we'd still say that x can't equal -2, +8, or -4. It does not matter what order you have those factors listed, and it does not matter which order you have your restrictions for x listed. So that would be your answer. All right, I want you guys to try this next one completely on your own. This is a combination of what we did yesterday and what we did today. So let me just move things over here. So I want you guys to go ahead and pause the video and hit play when you're ready to check to see if you've done this one correctly. All right, let's see what you did. So this one's a little bit less work. The denominator is x plus 5, x minus 5. So then we would identify our LCM here as x plus 5, x minus 5. And the second fraction already has what we need, so we don't need to change anything. And so our first fraction, again, is going to stay the same. Oops, I forgot to change this to be plus a -2, so make sure you do that. So then that second fraction, so the first fraction, again, we already have the denominator we need. So the second fraction, we need to multiply the top and bottom by what's missing, which is x minus 5. Okay, so our denominator, we know what that's supposed to be. Our numerator, didn't have to do anything to that first one. The second one, I distribute the -2 through, so it becomes -2x plus 10. And now let's combine like terms. So 3x minus 2x, that's just 1x. -5 plus 10 is +5. Now you should recognize that x plus 5 and x plus 5 cancel out. So we're left with 1 in the numerator. So if the numerator disappears, it's just 1. And our denominator is x minus 5. Now what x can't equal, so we would still go back to before we canceled anything out. And so we'd say -5 and 5 is our restrictions, for what x can't equal. So x can't equal -5 or 5. All right, we're not going to do the last part of your notes. That's where we're going to end. So good luck now as you work on your assignment.